Hi, what I want to be able to talk to you about tonight so that you can use this tomorrow in class during Day of Silence is that there are lots of ways to be able to find the equations out of these beautiful parabolas that we'll be examining over the next few weeks. I want you to just see that this example here is something that you know about already because you saw it today in class. So we have y equals x squared. And we can see that from the vertex, which is here's our minimum value, that from the vertex we go over 1 and up 1 from the original spot, from the vertex. Or if we went over 2, we go up 4. And we can see that that's happening from this table here from x squared, so xy. So we have 0, 1, 2. 0 squared is 0, 1 squared is 1, and 2 squared is 4. So depending upon how we behave, how the parabola behaves after the vertex, we can then see that this is just an x squared. Okay, now I'm going to show you a couple other different images, and we're going to talk through a few different ways that we can find the equations for these really great functions. So here you can see a couple things. One of them that I want to point out to you right away is that you have this intercept here and an intercept here. So we know that this is when y is equal to 0, so that's going to be really helpful. And so if it's when y is equal to 0, that this one here had to be x plus 1, because the negative 1 here, the negative 1 turned this into 0. The piece over here is going to be x minus 1, again, because if I plug in the positive 1 into that spot, I get 0 for that. So I can say that this is y equals x plus 1 times x minus 1. Some of you may also see this as being a little bit different, is that you may see this instead as this parabola here that then shifted down to this vertex here sitting at negative 1 instead of sitting at the origin. So that's sometimes another interesting way that someone else might say instead that the equation is y equals x squared minus 1. What I'm going to do on the next slide is I'm going to show you how we can actually use what we know about absolute value functions instead to identify parabolas, because sometimes this this method of finding the x-intercepts and then creating the equations isn't going to happen. So we're going to take that into consideration. So let's just refresh what we know about absolute value functions. Here is a vertex of, let's see, 2 comma negative 1. And I know my equation was y minus y sub 1. And some of you, again, had different equations that you used, but in general it was this. So y minus y sub 1 equals the absolute value of x minus x sub 1. So if I plug in this vertex into this one, I'm going to get y plus 1, because of y minus negative 1, equals the absolute value of x minus 2. So that's the equation for that. So we're going to use this same thinking to identify a parabola. It's going to be great. So taking a look at this parabola here, you can see that the vertex is sitting here at 2 comma negative 1. So we're going to use that same form we saw with absolute value functions with y minus y sub 1 equals x minus x sub 1. But this time, instead of it being in the absolute value, it's quantity squared. It's really, really important. And it behaves just like that y minus y sub 1 equals the absolute value of x minus x sub 1. It's the same relationship there. This should feel like point slope again. What I want you to see here is that I'm going to use this vertex point to plug it into this equation here. So I could just say instead y minus 2, oops, I'm so sorry. Ugh, that was terrible. Okay, let me just identify the vertex here for us instead. So this is the point 2 comma negative 1. All right, I apologize. So now I'm going to have y plus 1 equals equals in parentheses x minus 2 quantity squared. So I'm going to simplify this for you. X minus 2 quantity squared is the same thing as x squared minus 4x plus 4 equals y plus 1. And that's the same, if I move the y, that 1 over, I'm going to get x squared minus 4x plus 3. If I subtract 1 from both sides here. Here's my minus 1, minus 1. Okay, now what I'm instead going to do is I'm going to solve the equation for this parabola also. Instead, now I'm going to use it in intercept form. So that is instead when I am using this and this. So instead I would say y is equal to, and I have x, and I'm thinking about how to make this 0. So x minus 1, because that 1 if I plug it in would make it 0, and x minus 3, because if I plug in this 3 it turns that to 0. If I simplify this, look at what I get. I get y equals x squared with FOIL minus x minus 3x plus 3, which is y equals x squared minus 4x plus 3, which is the same exact equation that we had here. So if you want to use, you can either use, here you could either use, vertex form, which is here. You could use this vertex form, or you could use the intercept form. So let's get to why we would actually have to have both. Here's an example. Okay, so I don't have intercepts. I don't have any x-intercepts, so I can't write the equation of it this way. So I'm going to have to use vertex form, which, because you are seriously so well trained in absolute value function identification, this is a piece of cake. So again, it's y minus y sub 1 equals, the in parentheses, x minus x sub 1 quantity squared. So my vertex here is at negative 3, sorry, that's not dark enough. It is at negative 3, comma 1. So I'm just going to plug that in. And I get y minus 1 equals x plus 3, because it's x minus negative 3, quantity squared. That's the equation to describe that. If I wanted to, I can simplify it, but you don't have to. So if you feel fine with this, you are totally and completely done with the equation of this parabola. If you want to simplify it, you get y minus 1 equals x squared plus 6x plus 9, and then I would just add 1 to both sides, and I get y equals x squared plus 6x plus 10. And then we'll talk about this, but I want you to realize right away, this one here does not factor. I can't multiply to 10 and add to 6. And I want you to really start thinking about why is that happening with what's happening in regard to the graph. So what I'd like you to do right now is I want you to pause the video now and write the equation for this parabola. Okay, so I'm hoping that you've written that on your own. I trust you. And what I'm going to do is I'm going to just talk the way that I would go through this one. And again, this is a really good example of why I can't use intercept form, because I can't see exactly what the intercepts are. I could guess, but I have no idea what they really are. However, this vertex is just totally right there for me to use. So I'm going to go back to that y minus y sub 1 equals x minus x sub 1 quantity squared. My vertex is at the point negative 2, negative 2. So I'm just going to plug that in. Y minus negative 2, so that's y plus 2 equals x minus 2 quantity squared. Again, I'm totally finished if I want to. I don't have to use it at all. I don't have to simplify it at all. But I'm going to, just in case you want to, y equals, I'll put, this is x squared minus 4x plus 4, and I'm going to subtract that 2 from this side. So I get y equals x squared minus 4x plus 2. And here you might want to be thinking, this does not factor. How does that go back to this graph? What does that tell you? All right, we'll practice this the whole time in class on Friday. Thank you.